All right, so we'll finish up this week by looking at section 8.1. The take-home test will just cover the first part of section 8.1. We'll do the second part of 8.1 tomorrow. So the idea in this section is we're solving triangles again, which means to find out how long are all the sides, how big are all the angles. I always have to give you 3 pieces of information, okay, to start with, and you have to find the other 3. Now, when we did this before, what kind of triangles did we work with? Does anyone remember? Yeah? We always worked with a right triangle. So that was one of the pieces of information that was always given. This time, we're going to solve triangles again, but we're not going to work with right triangles. If we happen to have a right triangle, that's great. It's easier. You can use what you already know. But if you don't have a right triangle, some of the stuff I taught you doesn't work anymore. What happens if you don't have a right angle in a triangle? What else don't you have? You don't have a hypotenuse. Okay, so that means Pythagorean theorem doesn't work, because Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. Can't use it anymore. You also can't use the SOHCAHTOA. Sine is opposite over hypotenuse, you don't have a hypotenuse. Okay, cosine is adjacent over hypotenuse, you can't use that stuff. So we got to look at something a little different when you have a triangle that's not a right triangle. Okay. So triangles that don't have a right angle in them are called oblique triangles. And there's really 2 types of oblique triangles you can have. You could have an acute triangle, and you could have an obtuse triangle. Okay. An example of an acute triangle that's oblique, a common one, think of equilateral. The angles are 60, 60, and 60. That would be a very easy problem to solve because an equilateral triangle, all the sides are what? The same. So we usually don't look at ones quite like that. But that is an example of an acute triangle. All angles less than 90. Obtuse, you can have one angle bigger than 90. How come you can't have 2 angles bigger than 90? Yeah, it wouldn't be a triangle. Okay, triangles have to add up to 180. If you have 2 angles bigger than 90, well, that doesn't leave much for the 3rd angle. So when I draw triangles, keep in mind, I never draw them to scale. Okay? The only thing that's going to be important is how you label things, but they don't have to be drawn to scale. Okay, and that's the diagram that I always use when I'm solving a triangle. Okay, some of these letters you'll already recognize. A, B, and C are the sides. How about the name of this angle across from A? That's alpha. And the name of the angle across from B is beta. Now, when we solved triangles before, these were the only 2 angles we had to name because the other angle was always a 90. So we didn't need to give it a name. Now the angle across from C, remember C is not a hypotenuse, we're going to have to give it a name. Does anybody know the name of that Greek letter? It's gamma. Yeah. So you can draw your triangle any way you want, as long as you always put side A across from alpha, side B across from beta, and side C across from gamma. Okay, you have to maintain those relationships. And I'm not implying that C is always the longest side. Okay, my diagrams are not to scale. So there's a couple different types of problems you can solve here. Let's see. Depending on the information I give you, there's 2 laws we're going to learn. Okay, one of them is the law of sines. Anyone have a guess what the other law is? Cosines. We're not doing cosines for it. That's the next section. So we won't get to that till after break. If it's a law of sines problem, there's 2 cases I can give you. Okay. I either have to give you 2 angles and a side. And let me draw that out. Okay? If I were to give you 2 angles and a side, it could look something like this. Let's say this angle is 10 degrees. This angle is 100. And this side is 7. That's an example of angle, side, angle. The reason is because the side that I gave you is between the two angles.
Did we do something like this in geometry?
In geometry, you use like theorems and postulates that were called these. I'm just using these as abbreviations for information that you're given. But yeah, there is some stuff with geometry, but a little bit different usage. Those are more proofs. These are not. But yep, you did see these words or abbreviations in geometry. All right, and then side angle angle could look something like this. Let's say this side is 10, this is 95, and this is 15. In this problem, you have two angles, and you also have a side, but the side that I gave you is not the one that's between the two angles. It's outside of the two angles. Same information, different placement. Any questions on the difference between those two types? Right, so if you have two angles and a side, this is one of the kinds of problems that we use law of sines for. Okay? The other type is if I give you two sides and an angle. All right, so that would look something like, let's say this is 6, this is 12, and this is 20 degrees. You know a side, you know another side, but the angle that you know is not the one between the sides. Okay, that would be this one. And in fact, if you know the angle that I had circled a second ago, that's a totally different kind of problem. That's law of cosines. So we're not even going to look at that until after break. Okay, and this one I put an asterisk next to it because it's a little tricky. When you have this type of problem, different things can happen. When you have an angle side angle, there's only one thing that can happen, and I'll show you what that is. When you have side angle angle, there's only one way to solve it. When you have side angle, there's three ways to solve it. And depending on the information they give you, they might have given you information that doesn't work, and you can't solve it. They might have given you information that you can solve it, and you only get one answer. Or the information they could give you leads to two answers. So there's three different things that can happen in this second case. And it's the only case you have to worry about that. Everything else we solve using law of sines, there's always one solution. Always. Except for the side angle case. Okay, so any questions on those three cases? All right, so to solve any of those three cases, we're going to use the law of sines. If you have a type other than one of these three, you don't use law of sines. You've got to use something different, which I'll show you after break. All right, so I'm going to draw a diagram. Okay, you can put the diagram right below this. My diagram's on a separate page. That's fine. But just put it right after this in your notes. And I'm going to show you how we get the law of sines. It's actually pretty very straightforward. To show you where it comes from, just start by drawing that triangle. Don't label anything on it yet. Okay, what I'm going to do is I'm only going to label two of the sides and two of the angles because I don't need the third side and the third angle for what I'm going to show you. So labeling it is just going to be more confusing. So let's call that side A, and let's call that side B. Now, because this side is A, what does the angle in the lower right have to be? It has to be alpha, and the angle in the lower left? beta. And again, I don't need the third side and the third angle for what I'm going to do. Okay, next thing I want to do is I want to split this into two triangles. Okay, triangles that we already know how to work with. So I'm going to split it into right triangles very simply by doing that. Okay, so what I just did is I created two right triangles. That line that I just drew, what is that? It's the what of this triangle? Not a fancy word, just kind of a basic idea. It's the line of the triangle? That's not really something we measure in a triangle. It's two-dimensional, so there's no cross-section really. Cross-section, when you have like a 3D thing, you slice it open. What does that measure?
Height?
It's the height, yeah. It's the height of the triangle. Now, I'm going to call it h. I don't want you to confuse it with hypotenuse, but just they both begin with the same letter, so I'm going to call it height. But somebody said amplitude. I think maybe you were thinking altitude, which altitude is the height of a triangle. All right, so now I want to block off the right-hand side. Okay, just focus on this triangle on the left. All right, I want to pick a function that would involve the three things I have labeled. This angle, this side, and that side. In this right triangle, side H is in what position compared to beta? There's three, it's opposite, yep. And side A is the, nope, it's not the adjacent. It's across from the 90, so it's the hypotenuse. So let's write down what we just said. The sine of beta equals, what's opposite beta? H, that's height. And what's the hypotenuse? A. Now, I want to get h by itself. So how would I move a to the other side? Multiply. So a sine beta equals the height. Just write that down. I'm going to come back to that in a second. A sine beta equals the height. Now I'm going to block off the left triangle, and I'm going to look and do the same thing on the right side. What trig function would involve this, and h? It's opposite and hypotenuse again. So what would the sine of alpha equal? H over b. And I want to do the same thing. I want to get h by itself again. What would h equal?
B sine alpha.
Yeah, you multiply both sides by b, and you get b sine alpha. So now let's look at the two things we have. I have a formula on the left for h, and I have a formula on the right for the same h. But what's in the two boxes? There's a connection between them. What's the connection between box 1 and box 2? Anybody see it?
They both equal h.
Yes, that's very important. They both equal h.
So they're equal to each other.
So they are equal to each other. That's the key. Box 1 and box 2 are two different ways of calculating the exact same thing. So let's write that down. Box 1, a sine beta equals box 2. Okay, and what I'd like to do is I want to move the a to the other side. So how would I move a so it can be over with alpha? What would I have to do to each side? Divide it by a. And I want to move b so it's over on the other side with beta. So let's divide by b. So if you do that, a's cancel. And here, the b's cancel. So what I get is the sine of beta divided by b equals the sine of alpha divided by a. And that's the first two parts to the law of sines. I have them written in a little bit different order. I wrote them alphabetical. Sine of alpha divided by a equals sine of beta divided by b. And there's a third part to the law that I didn't prove, but based on the pattern, anybody think they know what the third fraction is?
Sine of gamma equals C.
Sine of gamma
Divided by C.
divided by c. Okay. I didn't prove this last part. But you could very easily prove it just the way we did the first two, by drawing a triangle, and instead of labeling the two sides I did, pick two different sides. Okay? So I'm not going to go through it again. But this is the law of sines. Okay? And we proved the first two parts. And the idea with this law is you never use all three parts at the same time. You either use the first two parts, you can use the last two parts, or you can use the first part and the last part. Okay. Any questions on this law? Or where it comes from, basically figuring out these two boxes. So this law really is built from understanding right triangle trig. Okay? That's where it comes from. But it's going to give us a way to solve triangles that don't have right angles. Okay. What can we keep in mind about alpha, beta, and gamma? Those three angles in the triangle always add up to what? They always add up to 180. Okay, so that's a fact you can still use. Even though we don't have a right triangle anymore, it's still true. But Pythagorean theorem we can't use, and we can't really use anything else. So we're going to stick with using this law. I mean, it's pretty easy to remember. It's all fractions. And alpha goes with A, beta goes with B, gamma goes with C. Let's look at an example. Okay, so they want us to solve that triangle. Okay. First thing I usually do, just to organize all my information, is put my three sides in one column, put my three angles in the other column, and then fill in everything I know. 20, 60, 4. So I need B, I need C, and I need gamma. Anything I can find first there relatively quickly without too much work? Yep. Yeah, we can get gamma because we have two angles. They all have to add up to 180. So what's the third angle? 100. Now, if we were doing this problem with a right triangle, what would be my advice about using what we just figured out to find other stuff?
So if this is a right triangle, you're asking?
Yeah, if this was a right triangle, the way we did it before, what would I say about using what we just calculated to figure out other things? I would say don't use it, because, how come?
If it wasn't given, then you gotta go up there and-
Right. Because in a right triangle, I said if it wasn't given and you made a mistake finding it and you use it to find other things, you're going to get them wrong. Well, when we're doing law of sines, we can't really do it that way. We have to use things we calculated to find other things. So you have to use this angle to find C. Okay? You don't have to use this angle to find B. You have to use the 60, and that was given. So if you made a mistake finding gamma, you're going to get C wrong automatically. But you could still get B right, okay? So sometimes things like that, we can't avoid it. So let's find B first. Okay, so every time you do a law of sines problem, you're always going to pick two parts of the law to use. Out of these three rows, which one has everything in it?
What angles?
Row A. Okay? So row A is a very important row. You're going to use row A to solve for B, and you're going to use row A to solve for C. So let's fill in row A into the first part of my law. Sine of alpha divided by A. So it's sine of what?
20.
20 divided by 4. Now I want to solve for B. So what goes on this side has to be the part of the law that has a B in it. If I wanted to solve for C, I would put the part of the law that has the C in it. So if I'm solving for B, what would go on top here?
Sine 60.
Sine 60. And what would go on the bottom? B. So every time you do one of these problems, you have 4 spots. One of them should have a letter. The other 3 should all be numbers. What is this? When you have a fraction equal to a fraction? It's a proportion. And how do you solve a proportion? Cross multiply. So 4 times sine 60 equals what would go on the other side? Times? Yeah, and I'm going to write it like this. That way there's no confusion whether the B is part of the 20 or not. It's in front, so there's no confusion. And now my last step, to get B by itself, I got to get sine of 20 on the other side. So divide by sine 20. And divide by sine 20. And that's our answer. Okay, we need to type that in and round it off. But notice I didn't use a calculator for anything in this problem until the very last step. Okay. What would happen if you used the calculator at the first step and then rounded some things off, and then used it again at the second step, and then when you did the division in the third step, and then rounded again? What would happen? Yeah, your answer is going to get less and less accurate. In these kind of problems, round one time, and that's it. Round at the very last step. Okay. So now type it in. Okay. We will be working in degrees for all of these. So if you put your calculator in degrees for this section, you can always keep it there. Right. 4 sine 60 divided by sine 20. Okay. So B is 10.128. That's 10.128. That's pretty accurate. And now I have A and I have B. So can I use Pythagorean theorem to get C? No, why not?
This is not 90 degree.
Yeah, this isn't a right triangle. So you definitely can't use Pythagorean theorem. So we're going to find, this was to find B. Now I'll find C the same way. I have 2 choices. Row B has everything in it, and row A has everything in it. Okay? To use law of sines, you have to have a row with everything in it. Which one should I pick? Yeah, I should pick row A. How come?
Is it given? Is this?
Yeah, it was given. The answers are exact. Okay, row B, that's not an exact answer, and it's rounded. So we're going to start out with sine of 20 over 4. But what's going to go on the other side this time?
Sine 100 degrees over C.
Sine of 100 over C. So this is where if you made a mistake finding 100, we're going to get C wrong. Okay, so just don't make a mistake when you're doing that simple arithmetic. Make sure it adds up to 180. All right, and then if you want, you can do the cross multiply and divide all in one step. C is going to equal 4 sine 100 divided by sine 20. If you don't want to do it all in one step like I did, go back and do it like I did here. Do it in 2 steps. But after a while, if you get good at the cross multiplication, you can just do it all in one step. And that's your answer. Okay. I don't know exactly what it is, but I do know it should be the biggest side because it's across from the biggest angle. So it should be bigger than 10.128. So if somebody can find it, that would be good. But I also know it can't be bigger than these 2 sides added together. That's a rule in any triangle. Any side has to be smaller than the other two added together. So I guarantee you it's smaller than 14.128. Okay, so it's between 10 and 14. Does anybody have what that comes out to if you type it in? 11.518. Right, so that seems reasonable. It's between the two numbers that it should be. Bigger than 10, smaller than 14. Okay, and that's a law of sines problem. Any question on that? So all you really have to do to know if it's law of sines is make your table, and if you have a row with everything in it, that's law of sines. A row with everything in it guarantees you it's one of these three types. Okay. Let me show you one that's, just so you can see one that's not one of those types. Side, side, side. That's a type that's not in that list. And if I made my table and I filled in my three sides, that's what it would look like. Is there a row that has everything in it? No. That's why side, side, side can't be used with law of sines. Okay? So the shortcut to figuring out, do I have one of these three types? Make your table and look for a row with everything in it. Okay, let's try this one. Now this one, you have a diagram, so you could figure out what type it is without even having to draw anything. What type is this one? It's angle side angle. ASA. And ASA, if you look back, is one of the types. So I will have a row with everything in it. Okay, somebody tell me one thing that I know here. First, I just want to write down what I know first. And then I can get what I don't know. Alpha is 45. C is 4. Yep. Beta is 40. Now, I just guaranteed you that you would have a row with everything in it, because I said ASA is in the list of the types we're supposed to be able to do. Well, I don't directly have a row with everything in it, but can I get a row with everything in it? Yes, very easily. Okay. All we got to do is add those two angles up. 85, subtract from 180, and then how much?
Should be 85 or 95, right?
95. Now, this row is very important. This angle side angle is the kind of problem that if you made a mistake finding this, then everything is going to be wrong. It's not like only one thing might be wrong, everything is wrong. Because you're going to use row C to find B, and we're going to use row C to find A. So double check and make sure that you got that angle right. All right. So how would I set it up to find A? What would I start with? Great. Yeah, you always got to start with the row that you know. And now we're finding A. So what's going to go on the other side? Sine 45 over A. Okay, and Curtis, can you tell me when I cross multiply, you don't have to give me the decimal, but just tell me what A is, what times what divided by what?
It's 4 times sine 45 over sine 95.
Yep. Okay, so now type that in, see what you get. 4 sine 95, make sure you close the parenthesis, that's important. It's even more important, you type the number in, right? And then divide by sine 95. Yes, thank you. So A is 2.839. Now I have 2 rows with everything in it. Which row should I go back to find B? Yep, back to row C, because everything's exact. It wasn't given, but at least it's exact numbers. So, all right, Luke, can you tell me one side of my proportion to find B?
So the sine gamma equals, over C or equals.
And what's gamma?
I'm sorry, I didn't see. Can you go back up? 95
Over
over C, which is, I have to go back up again, 4.
4?
And then sine beta, which is 40, right?
Yep.
Over C. B.
We're finding B. Yep. Okay, cross multiply. Get B is 4 sine 40 divided by sine 95. Does anybody have their calculator and tell me what?
2.581.
2.581. Thank you. Okay, so when I'm done, a quick thing I do, make sure the biggest side is with the biggest angle, smallest side is with the smallest angle, and if you add any 2 sides together, it should always be bigger than the third. So that's 5 something, that works, that's 6 something, that works, and 6 something. So everything looks reasonable. There's nothing obviously wrong with it. Okay. Any questions on the second type, angle side angle? Okay, and the third type, we're going to spend the rest of today, we'll do one example and all of tomorrow. Okay, so the third type, that's the one where you can have different things that happen. Okay. The first 2 that we did, what I just did is always what happens. There's always one solution. Okay. This type is going to be side-side angle. Okay. If I didn't know that, you kind of know it after you do a lot of them by what's given, but if you label everything, let's let A be 3, B is 2, and put alpha across from A. Side, side, angle. Okay. So that's one that 3 things can happen. No solution, which is the fastest. 1 solution, which takes about the same amount of time as we just did. And 2 solution, which isn't harder, but you have to do everything twice because you get 2 answers. So it's like doing 2 problems at once. Okay, so we're going to solve the one where A is 3, B is 2, alpha is 40. Okay. And I just copied that information into my table. Now, how do I know that this is a law of sines problem, looking at the table, if I didn't have the diagram? What was the trick I told you? Yeah. If you have one row with everything in it, that's how you know it's law of sines. And then if you have one row with absolutely nothing you can find, that's how you know it's the case that's 1, 0, or 2 solutions. None of the other problems had a row that was completely empty when we started. This one does. So because that row is completely empty, you can't do anything with it. So what do you think you have to find first here? Gamma's in the row with nothing in it, so you can't do anything with that row. To find gamma, you have to know C. You have to find beta, okay? Because you have B, so you can do it. Okay? And this one's a little different because we've never had to solve for an angle before. We've always had 2, and we could add them up and subtract from 180. So let's set it up and see what happens. What would I put on the left side? Sine 40 over 3 equals beta over 2. Okay, we'll cross multiply. I'll just show this one out. 2 sine 40 equals 3 sine beta. 2 steps left to get beta by itself. What's my next step?
Divide by 3 is
Remember, we can't divide by a function. That's a word. Divide by 3. So divide each side by 3. So now we have 2 sine 40 divided by 3 equals sine beta. But I want beta, not sine beta.
So take the inverse of sine.
Yeah, take the inverse sine and take the inverse sine. Now, whenever you take inverse, how many answers do you have to look for?
2.
You have to look for 2. Now, I can guarantee you the quadrants it's going to be in. Think about the fact we're working in with a triangle. What quadrants do my answers have to be in? And 2. Why couldn't I have an answer in quadrant 3?
Because it'd be angles. Then they'd be negative.
Right. Yeah, there's a couple reasons. First of all, if you're in quadrant 3, your angles are 180 to 270. You can't have angles that big. And if you're in quadrant 4, they're even bigger. So the 2 answers have to be in quadrants 1 and 2. The other way you can think about it, you're looking for where sine is positive, right? These numbers are all generated from side lengths, which are positive numbers. You would never have a negative side length. Okay? So let's figure out what that is. Inverse sine of 2 sine 40 divided by 3. I get an answer of 25.374. Okay, I'm going to write that in the top of the box. Just in case there's a second answer, I'll put that in the bottom of the box. That's my reference angle. How would you find your second answer using that as your reference angle? 180 minus that. So technically, the other answer to this problem is 154.626. But now we're restricted by the fact we're working in a triangle. So would this other answer work in the triangle? Why doesn't that answer work?
Because the other length is too small.
We already have the 40. That was given. So we're guaranteed we have a 40. Can you fit 154 and a 40 in the same triangle? No. That's the reason why the second answer doesn't work. Okay. It's a little weird. So this, you already really know this. Okay? To check if there's a second answer, you do 180 minus your reference angle. If you want to write it again, you can. When I scroll, it's going to be a little weird. I don't know why.
Switch the matrix.
Yeah.
You're the one.
So do 180 minus your reference angle. That's how you check if there's a second answer. And this is the only kind of problem you have to do that. The first 2 types we did in class, you never have to do this. Okay? It's only because we did inverse sine. Then once you get the first answer, okay, we got 25 point, whatever it was, about 25.4. Subtract it from 180. The other answer was 154.626. But we were given a 40 to start, so the other answer is too big. Right. So now we can rule out the second answer. How would I get gamma now that I have alpha and beta?
Add them and then subtract them.
Yeah. All you have to do now, it's just like a normal problem. That's 65.374. And you get 114.626. And now, you finally have a piece of information in the last row, so you could set up your proportion to find C. Okay? Sine of 40 over 3 equals sine of 114 over C. Okay? But the trick you had to figure out first was do beta, then gamma, then C. You have to do it in that order. You can't do it in any other order. Okay? Okay, so that's only with the side angle type. That's the hardest type. Okay, we didn't go over what happens when there's no solution or two solutions, so I wouldn't worry as much about that on the test at this point. Right? That's going to be 8.1 part 2. Okay, so the homework tonight is really the take home, and it's due tomorrow at 8:35. Even if you're out, it's still due. If you're going to be out and you want to wait to take it till after vacation, that's fine, but it's going to be 3 weeks from now. Okay? Late tests, if you turned it in late, would be a 0. Any questions on that?